Eurofighter is a very powerful airplane.
It's what the pilot really wants to have in their hands.
It's the most advanced multi-role combat aircraft in the world. And it's a battle to build. Kilometers of wires.
It's not that we go and get a Microsoft package off the shelf.
Thousands of parts.
It does look like a mess, but we make the same mess every time.
A superjet model kit with different parts made across 4 factories in 4 countries, all speaking different languages. And it all has to fit together and fly.
Of course, you can't build the aircraft unless all the parts arrive on time.
Enter the European Megafactories that build the Eurofighter Typhoon. A gauntlet is thrown down to some of Europe's top engineers. Design the world's best fighter. Able to fly twice the speed of sound. Outmaneuver anything in the sky. And pack enough firepower to wipe out a small air force. After decades at the drawing board, 4 European countries, Italy, Spain, England and Germany, join forces. It's the biggest industrial collaboration in European history, formed solely to create one aircraft. The Eurofighter Typhoon. The best combat aircraft you can buy. And a guardian of safety under which millions of Europeans sleep. Now comes an even bigger challenge. Building it. Because it's not made under one roof. It's not even made in one country. The 4 partner countries fabricate 7 major parts and thousands of connecting pieces. And somehow, all those pieces from all those places must come together to form a single, flawless fighter.
It is an extremely advanced fighter plane, the most advanced ever built in Europe. If you made a comparison to automobiles, it would probably be the Ferrari of the skies.
It's the most complicated model aircraft kit in the world. And it's made for the most demanding customers.
It's really fun to fly. It is, from a fighter pilot point of view, really easy to fly compared to older airplanes.
As every expert modeler knows, the perfect end result begins with collecting and laying out all the parts. The Typhoon has thousands of components, but most importantly, 7 major pieces. Each partner country puts in a share of the money, so each gets a share of the bill. It's the ultimate in building by committee. But with so many cooks in this engineering kitchen, all speaking different languages, will it work? The parts rolling through the Eurofighter Megafactories are the result of an epic battle, a struggle between strength and speed, integrity and maneuverability. That means merging the capabilities of multiple aircraft into one. To meet these design challenges, engineers invent whole new ways of manufacturing. To add further to the complications of the multi-nation build, each individual part comes with its own unique challenge. Italy, close to Turin, at the Alenia Aerospace Megafactory, their 21% share of the consortium includes the left wing and part of the rear fuselage, parts 1 and 2 of the model. This rear fuselage holds the engines. Military pilots need firepower, so designers place these Rolls-Royce Super Beasts at the back saving underwing space for weapons.
Sotto appunto l'ala sono presenti varie, stazioni.
Underneath the wing, there are various stations for the support of weapons, of weaponry. In particular, at the outboard pylon, in this case, an infrared missile is present.
In questo caso presente un missile all'infrarosso e c'è ovviamente un dummy, ma è così comunque rappresentativo di essenzialmente.
It is obviously a dummy. However, it is representative of a short-range infrared weapon. And we have other pylons. We have an inboard pylon in medium wing, and it is possible to mount a combination of tanks and missiles in an adequate number for the mission. Very important.
The challenge here is providing enough strength to cope with the intense heat and excessive vibration while keeping the weight as low as possible. The solution? Titanium. It's as strong as steel, yet 45% lighter. But it takes more than ordinary titanium to meet the demands of the Typhoon. So the Italian partners use a unique process called superplastic forming diffusion bonding. Layers of titanium are blasted to around 1000 degrees, turning the metal into a plastic-like state. Gas is injected, adding ridge-like ribs across the panel. This adds strength. Alessandro De Benedetto is Typhoon's production manager.
You get panels that are very resistant, like I said, from the point of view of temperature resistance, but also very lightweight because titanium obviously has a very low specific weight. It is also very resistant from a mechanical point of view, because these bubbles are from the actual ribs that guarantee the component an elevated capacity for resistance to flexion and twisting.
The superformed titanium inner skin is covered with carbon fiber. In fact, a massive 70% of this airframe is made from carbon fiber composites. Another weight-reducing measure. Because when you need to get off the ground quickly, weight matters.
It's really light for a fighter jet. As you can see, when you use the reheat for the takeoff, you're off the ground in just no time. Compared to old aircraft, they need the reheat to get off the ground anyway. You can fly really high, really fast.
So fast, it takes less than 90 seconds for this superjet to shoot from the runway to a height of over 9 kilometers. And incredibly, just like all model aircraft kits, much of this fighter jet's carbon fiber skin is reinforced with glue. Carbon composite is made like phyllo pastry. Thin sheets of carbon material are cut to size and stacked in layers. Once heated, they bond, creating one of the strongest materials by weight in the world. Flying in a giant model aircraft made with plastic and glue might make most of us want to stay on the ground, but the Typhoon's test pilots have no such fears.
When you review the past and all the pilots and all their experiences, that was something different. Now, behind us, there are such a big engineering, so many people thinking and working and designing and producing and doing the things in the right way. So when we jump into the aircraft, we feel very confident.
Just to add to the already complicated mix, the Italian crews can't complete this part until the last piece is made and shipped over from the factory in England. But one component made entirely in Italy is the left wing, part 2 of the model. In their basic form, aircraft wings appear pretty simple. But it takes more than joining top and bottom to put this section of the plane together. The lower wing has a skeleton of horizontal spars. But instead of rows of rivets, these bars are glued in place, creating a perfectly fused bond. Technological genius, taking even more kilos off that all-important total tonnage.
Come potete vedere, questi elementi verticali che noi chiamiamo
As you can see, these vertical elements are what we call spars. These spars are fully glued to the structure of the lower panel in order to allow the overall structure strong savings in terms of weight.
Incredibly, the world's best fighter aircraft is designed to fly badly. This vast triangular structure is called a delta wing, and amazingly its shape and where it fits on the aircraft makes the Typhoon inherently unstable at low speeds. But hit the power, and this oddly awkward design is the ultimate flying machine. This jet doesn't cruise at low speed. It outruns the speed of sound. And could cover London to Paris in 20 minutes. On the ground, the teams install cross ribs. These linking struts reinforce the bonded horizontal planes, providing angles to attach inner wing hardware. Little else is added to the structure, because the single largest component of the Typhoon's wing is fuel. It's what aeronautical engineers call a wet wing.
Inside the wing there's a forward and an aft section of fuel tanks, so it's basically 2 fuel tanks in there. And the beauty of it is you don't have to do anything. The aircraft takes the fuel from the tanks it needs for the center of gravity adjustment, stuff like that. So you don't have to do any manual control which tank is used for flying right now. The aircraft does that all by himself.
And a wet wing has an operational advantage. Carrying fuel inside means no fixed underwing fuel tanks. Again, more space for weapons. The Typhoon is designed to fight. Born in the late 80s, it was conceived to defend against the raging Cold War threats. But by the time the deal was signed, the Cold War is over. But another war is simmering, one with extremists. Tomorrow, a Typhoon may be your first line of defense against the tactics of terror. The world changed during the years of the Typhoon's design, but it hasn't had to return to the drawing board. It's so advanced that it steps straight into the job. While the Typhoon takes its fight to the skies, in the Eurofighter Megafactories, a quieter battle goes on, putting together this multi-million euro aeroplane. And just one single component poses 1,000 challenges. Construction teams drill holes to fix the top and bottom wing together. Contact between the drill and the wing will cause sparks to fly, so water is added to the mix for safety. Precision is crucial. This part of the model must connect seamlessly with 4 other major pieces made hundreds of kilometers away. At least, that's the theory. For this to work in practice, Tolerances are accurate to within a width of a human hair.
Because we drill material of a diverse nature, principally a composite of carbon fiber, aluminium and titanium, the machine must guarantee the maximum precision during drilling. Every hole is initiated in one of the materials and completed in another. Therefore, it is very important that the drilling tool succeeds in finding its correct hole in one single pass.
There's a lot of holes to be drilled, but take away the glue and it would need 5,000 more. Less rivets mean less risk. Under flight conditions, an airframe flexes and moves. Just the slightest wiggle room in a riveted connection can cause metal fatigue, creating cracks. A wet wing is not just skin, bone, glue and precision drilling. Subcomponents are needed to make the wing whole. Flaperons, slats, hydraulics and electrics are all crucial for this model to fly. EADS Casa is based just outside Madrid. This Spanish megafactory owns 13% of Eurofighter. It makes the right wing, Part 3, and the only major part built here.
What you're seeing here is the installation of all the electrical phase and the hydraulic phase, all that allows us the movement of the flaperons and slats. We also attach all the coverings of the different phases of the different parts that the wing is later equipped with.
It's déjà vu as the Spanish engineers build their wing in an exact mirror image of the Italian factory.
The first things we receive are the primary pieces, and there are different types. We have what are the skins and the metal parts, which is the first division. Then we also have the parts for the systems, such as the wiring, the hydraulic piping, and the fuel piping.
Before each part of the model is finished, it must pass numerous tests. A major concern for a wet wing is fuel leaks.
The wing is anchored by the hardware zones, and we make movements to simulate the behavior that you can have when the wing is full of fuel. Since a wing in flight is not the same as a stationary wing.
After weeks of engineering, the wing is ready to leave its Spanish birthplace.
Here what we have is a completely finished wing, a wing that's passed through the painting phase and has passed through all of the installation phases of all the electrical and hydraulic systems. It's a wing that's already been equipped with the slats and flaperons.
Parts 2 and 3 of the model are ready. These twin wings, born hundreds of kilometers apart, will eventually be reunited on the finished Typhoon. But before building can begin, there's a few more parts to be collected. Samlesbury is home to BAE Systems, 33% shareholder of the consortium.
Within this hangar we produce the major assemblies for the front fuselage, including the canopy and the windscreen. We also produce the rear fuselage assembly and engine bay doors, fin and rudder flying surfaces and foreplanes.
It's one of the biggest aircraft assembly plants in the UK. Look closely across this Eurofighter megafactory, and there's something missing. Robots.
The robotic side of the business is mainly the detail manufacture, and machining manufacture is in the detail, but the assembly is very hands-on and requires a high level of skill dexterity, which our craftsmen have.
The lack of automation adds a further challenge to this mega model: human error. Every part of the aircraft must align perfectly. There's no room for any mistakes when flying at 16,000 meters and 2,000 kilometers per hour. Achieving this level of precision across 4 factories, hundreds of kilometers apart, without the accuracy of machines, is a testament to the skill and expertise of the Typhoon's engineers and designers. And this requirement for hands-on skill has added a positive twist to the project. The Eurofighter Consortium creates over 100,000 jobs across Europe. At Samlesbury, parts are moved into position. The largest of the UK-made components is the front fuselage, part 4 of the model. This single piece contains 5,500 parts. But first up are the engine bay doors, the last major component needed to finish part 1, the rear fuselage. But these are no ordinary doors. Like the wings, they're made by superplastic forming. Back in Italy, the bay doors will be added to the rear fuselage. Part 1 is complete. Three major parts of the model are now ready: the left wing, right wing, and rear fuselage. Now part 4, the front fuselage, the cockpit. This cockpit is made of carbon composite, titanium and aluminium. And with thousands of individual components, it's one of the most challenging parts of the model to build. Mark Jackson is head of Typhoon's production engineering.
The assembly itself was the most technically challenging aspect of front fuselage, so perhaps not one component in its own right, but to design and engineer the fuselage product against a very, very demanding technical specification.
Luckily, every one of the Typhoon Megafactories gets a copy of the instructions. Operating the Typhoon's automated systems takes 45 kilometers of wires and 40,000 connections. Every one precisely fitted and thoroughly checked.
This is basically the cockpit of the aircraft. So all the flying controls, the throttle, it's like the command centre of the aircraft.
This rat's nest of cables will eventually protect the pilot's life, so it needs expert engineering.
It does look like a mess, but we make the same mess every time. It's very well engineered.
Electricians lay out each individual circuit. Then the circuits combine into one system. It's a time-consuming job.
When the looms come over, it takes about 3 days to put all the looms on, tie it together.
It then takes a further week to complete the wiring inside the fake cockpit. The replica layout is added to the real fuselage for testing. Believe it or not, this will eventually look like this. It seems cramped, but this is first class, fighter style.
The cramped impression you have, that's not really applicable, because it's for an aircraft or fighter jet cockpit, is really big cockpit. It's pretty roomy actually. The longest I've flown was about 9 hours with air refueling. and I didn't get tired at all sitting in the cockpit. So it's really nice. The air conditioning works. It's not really noisy up there. I mean, obviously there's some noise, but compared to older airplanes, it's a really comfortable cockpit.
Another pilot's aid included in the front fuselage is the flight refueling probe. This allows the pilots to take on fuel during flights, greatly extending their operational range. With the electrics signed off, carbon fibre skins are added and more glue. Reinforcing sealant is spread across the joints. This protects the structure and helps keep moisture out. Then, more drilling. Just like the wings in Italy and Spain, the placement of the drill holes is crucial. This part must also connect to other parts made hundreds of kilometers away. If the holes don't line up, this aircraft will be grounded. Holes are bored for temporary fasteners. These will hold the skins in place until permanently fixed. And it's not going there until these guys say so. They check for tolerances. One of the biggest challenges for the Typhoon's engineers is making sure every part of this model lines up perfectly, no matter where it's made. Many aircraft are allowed a 25mm lateral difference along the line from the tail to the nose. The Typhoon is accurate to within 1.5mm.
We can measure anything. We can measure hull positions, surfaces of the aircraft, anything really.
This 3D laser makes sure the Typhoon's parts are perfectly aligned. There can be no surprises further down the line. The laser itself does the work of a small army.
Depending on what you're measuring, this particular job takes about an hour probably to measure, and it's about the same to analyse. Whereas if you're doing it the old-fashioned way, the expenditure of the tooling and the actual manpower on it as well, you're talking a lot longer. Maybe half a day, maybe longer.
With its major parts installed and the sign-off from alignment, Part 4 of the Typhoon is ready to add to the kit. Next, Part 5. To add stability to the Typhoon's unstable delta wing design, it needs these. Sticking out from the front of the aircraft are the foreplanes, or canards. They act as mini wings, helping to balance the airframe.
This is basically the parking position, which is all the way full down. As soon as we enter the flying mode of the airplane, they go streamlined to be aligned with the whole airplane. And then I can control these directly with the stick as well. If I pull aft, they move upwards, so to allow the aircraft to raise the nose. If I push forward, same goes down with the nose.
These foreplanes are also constructed from super plastically formed diffusion bonded titanium, like the rear fuselage. And they're strong. Part 5, checked off the list. The English Megafactory also makes Part 6, the tail fin. Also made from carbon fibre composite, the tail fin provides lateral stability and it protects the aircraft's communication systems. Only one part is left before this model can be assembled. The centre fuselage, Part 7. This central tube is built by the German partner, 33% owners of the Typhoon. Everything except the canards and tail fin connects to this central pivot. And like the wings, it too is one giant fuel tank. The kit is ready. Now for the biggest challenge of all. 7 major parts, built at 4 factories spread across Europe, must come together as a single superjet. The parts are distributed among the Eurofighter factories. Each receives a complete set, ready to construct their model together. In England, at the BAE Megafactory in Wharton, they build Typhoons for the British Air Force. First job, laying out the pieces. Part 1, the rear fuselage. Parts 2 and 3, the wings. Part 4, the front fuselage and cockpit. Part 5, the canards. Part 6, the tail fin. Part 7, the centre fuselage.
Basically what we do is we take the major unit products, so the fuselage sections, the front fuselage, centre fuselage, rear fuselage and wings. We assemble those all together. We then make off all the electrical connections. We then put all the computers into the aircraft. We test the aircraft, we fly it, we paint it and ultimately deliver it onto the end user, into the RAF.
With an instruction diagram in 4 languages and 25 aircraft to be delivered this year, this is easier said than done.
1 every 2 weeks is a heck of a challenge. Given that all these parts come from all around the world, you know, the major components travel from around Europe, and actually pulling this all together in one location is obviously quite a headache, and to be doing that 25 times a year is quite a challenge.
First job, connecting the rear, centre and front fuselage. It begins with that crucial alignment. A challenge for aircraft fitter John Beresford.
Well, here in the laser alignment facility, the front fuselage is loaded in, and centre fuselage, and the tools are brought in, and the front fuselage and centre fuselage are married up and using the laser alignment tooling.
Each section is bolted together, then reinforcing strips are added.
In a minute, we're working on the rear fuse to centre fuse. This panel is a stress panel, and it allows stress to be built into the external structure of the aircraft. This area is quite an important area. These fasteners need to be correctly installed. The engines are in this area, so there's a lot of vibration as well, so we need to make sure that these are correctly installed.
They have a few tools on hand to help with their model.
This is one of the tools that we use. This is actually attached to the aircraft in a manner that allows the operator to drill off all the holes to the correct size.
Then, just to be safe, more glue.
We'll apply a sealant, and this sealant protects the panel and the structure from any water ingress, and prevents corrosion.
Putting together a multi-million euro fighter jet is a huge responsibility. But for these guys, it's worth every moment.
It's great working on the aircraft, and people enjoy what they do here. I really like to go up in one, yeah. It's a kind of dream of mine to do that.
It takes weeks to complete the fuselage. Then the wings are added.
The wing is connected by 6 large bolts. We have 3 main attachment points. This is the centre one. We use this as the datum point for the whole of the wing.
And it's reassuring to know that even the world's best engineers have bad days.
Listen to this now. I can't believe it. Drills is broken.
The difference is, these guys just build another one and carry on. The tools across the plant are air-powered, eliminating any fire risk from sparks. Installing the wings has to be timed to perfection.
Safe to say that once you put one on, you have to put the other on, because the actual legs fit into the wings, and therefore it becomes unstable at that point in time.
Further down the production line, the canards and tail fin are added. Finally, it looks like an aircraft. All that's missing is a means of takeoff. Twin Rolls-Royce engines give the Typhoon its power. But like every other component on this mega model, timing the installation is crucial.
The engines we put in more or less at the same time as we put all the computers and the equipment in. Again, it's a centre of gravity point of view. If we were to fit the engines before we fit, say, all the computers in the front fuselage, the actual aircraft would become two-tail heavy and it would actually sit on its backside. That is because the aircraft is so light.
The 7 major parts and thousands of components made in 4 countries are combined. But the aircraft isn't ready yet. There's one more job to do before this Typhoon can take to the air. Like every model aircraft, the Typhoon operates by remote control.
The aircraft is controlled by computers. The human input is more around flying the mission and the actual delivery of the weapon. But the aircraft is flown by computers, it's operated by computers, and without the computers it simply wouldn't be able to operate.
A simple computer virus could be fatal. To keep bugs out, few hands are allowed in.
Getting software onto the aircraft is all very, very highly security cleared, and there's only certain individuals within the company can introduce software into the aircraft. And it's not that we go and get a Microsoft package off the shelf and introduce it onto Typhoon.
The British model is ready. But before they're given flight clearance, the Typhoons must take a short diversion. Aircraft systems are exposed to more than enemy attack. They're at risk from threats no eye can see. Wherever they're made, every Typhoon arrives at one of these. It's called an anechoic chamber. And this one, at Alenia Aerospace in Italy, is the biggest in Europe. The abstract wall covering is made up of 11,000 sponge-like pyramids. These chambers are often used to test acoustics, as they absorb sound. But this room is used to test the Typhoon's vulnerability to electromagnetism, an invisible natural force that can fry the onboard instruments. These tests happen on every new aircraft, whether passenger or fighter jets.
Every aircraft, by regulation, must be checked for resistance to electromagnetic fields. Nevertheless, sophisticated defence aircraft, such as the Eurofighter, need a very high level of testing.
Not only does the room virtually create flight conditions, the Typhoon actually gets off the ground.
The aircraft can be lifted to a height of 15 meters to permit the closing of the landing gear, and thereby reconstruct a condition which is very similar to that of an operational flight.
In operational flight, the onboard systems protected by this test control everything. How pilot and plane interact is called the human-machine interface.
There are really few switches that you have to use. All the switches are in nice reach, so you don't have to turn around and flip switches all the way in the back. That's one thing you have to do on the ground maybe to start them up. But once you're airborne, everything lays in your hand. We call that HOTAS, hands-on throttle and stick, so you don't have to take your hand off the controls to do any manipulation in the jet.
And the Typhoon goes beyond fly-by-wire. This megajet can be operated in the blink of an eye. A key component of the most advanced fighter on the market is what the pilot wears on his head.
The helmet takes information from the aircraft's systems and it places on a visor in front of the pilot's eyes. It also cues you as to where you should be looking. So you get an arrow pointing to look this way, that way look up to target the enemy. You can look through the cockpit floor of the aircraft and still acquire a target with a helmet.
That means the pilot can simply look in the direction of his enemy and the aircraft systems will know where to fire.
I'm now really in a situation where I only really need to see the adversary and not to manoeuvre my aircraft behind for me to be able to take a valid shot or stand an increased level of getting rid of the target.
Voice control is also built into the helmets.
Attraverso comandi vocali, praticamente velivolo riconosce.
Through voice command, the aircraft recognizes the voice input and essentially commands an aviation selection. This is very convenient in air combat, under elevated conditions, in that it is possible to carry out all the required functions without ever lifting a hand from the stick, which under increasing G levels would be extremely demanding, if not impossible. And on top of this, the vocal commands do all the rest.
Sarebbe estremamente faticoso, se non addirittura impossibile, e on top of questo i comandi vocali fanno il resto.
Each helmet is uniquely programmed to its specific pilot.
And the liner is scanned to the pilot's own head size. Also, there are various parameters that are particular to the pilot that are built into the optics, which means again that it's very personal. It is personalised. So overall, a complex helmet and a very robust one as well. It really is, you know, from our pilot's perspective, going to revolutionise, I think, pretty much the way we conduct air combat in the future.
As impossible as it seems, this multinational collaboration is a success. 7 major pieces and thousands of components made across 4 countries and in 4 languages all fit together. This model is complete. It's time to put the aircraft to the ultimate test. This Luftwaffe base in Lager, Germany, has one of the largest fleets of Typhoons in Europe and one of the world's most experienced Eurofighter flight squadrons.
Good morning, everybody. Unstable air over our area is causing widespread low clouds. North of Berlin, tops of clouds around about flight level 70, south of them, cirrus above.
Before this team takes to the skies, ground engineers conduct flight checks. These happen before and after every flight. It's a carefully regimented process. The Typhoon is cleared for takeoff. Typhoon is an engineering masterpiece, precisely tooled against impossible odds. It may be the most complicated model aircraft ever built, but everyone agrees it's a master in the air.
When I flew a Eurofighter for the first time, it was immediately love at first sight. It is a fantastic airplane, probably the best I've ever flown.
Typhoon is a real delight to fly, and I mean really stunning performance that will take anyone's breath away.
It's the best thing that's out there, and obviously it's really fun to fly it.
When you jump into this awesome aircraft and just put thrust on it. It's amazing the power it has behind.